Alright, ladies and gentlemen, we're going to take a couple minutes here and go over Density Worksheet 1. I'm going to try to show you how to do some of the problems. I'm not going to go over every single problem here in the video. I'll show all the work and kind of point some things out that'll help you along the way. This first page is just the raw answers. I want to be clear, if you were to just show me these answers on a test, you would not get full credit. I need to see some of your work. I've said this before and I'll say it again. I have to see some of your work in order for you to receive full credit. That way I can kind of track down what you're doing and help you get better. I'm going to go ahead on to the next slide here. If you need to jot down these answers, leave plenty of space for the work though. So in our first two questions, we have to carefully read through the problem. We have a mass that's given as 387.90. You can see I've identified that as the mass. And we have a volume of 6.34 milliliters. I wrote down the density equation, and then I plugged in the mass and volume into those two variables. And then I did the division. The last piece for every math problem we do is always the rounding based upon the rules of significant figures. So my calculator said 61.1829653. I obviously don't need all of those values. So when I did the division, I had 5 significant figures and I had 3 significant figures. And since the lesser value only has 3, I'm only going to use the first 3 values, and the rest of values have to be rounded away, which is why the final answer is 61.2. And then of course we have the units in the answer. The mass is in grams, the volume is milliliters, so we have grams over milliliters in our units. Number 2, we have a cylinder. Anytime I see a cylinder, I always assume I'm going to need the volume of a cylinder equation, so let me just jot that down real quick over here. That's pi r squared h, where r is the radius. And then as I read the rest of the question, my assumption was true. The height was given as 5.43, and then the diameter was given. Well, the diameter and the radius are not the same thing. The diameter is all the way across the circle, the radius is halfway across, so I took the diameter and cut it in half so that I would have the radius. Now, you could go ahead and plug those values right into this volume equation, and if you do that, you're going to get 38.63 da 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 for the volume. Or you could plug it in where volume is in the density equation. You could do it either way. So it says the sample has a mass of 35.17, so I put that in for mass. And then on the bottom I have the volume. And again, I just used 38.63 da 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 da. So when you do the mass divided by the volume, you need to round your answer. It actually came out to 0.910227, and it keeps going and going. So how many significant figures should I have in my answer? Well, let's go back to the original problem. I have 3 significant figures in the height. I have 3 significant figures in the diameter. I have 4 significant figures in the mass. So since 3 is the lowest, I should write down the first 3. So that's why I have this amended answer here in the nicely drawn blue box, 0.910 grams per cubic centimeter. Yes, you do have to include the 0 to the right. That is the estimate. You might notice that this original answer is slightly different. I believe what happened there is I rounded the volume. I believe I took this mass and that rounded volume and I divided the two and I got that answer. It's not a huge difference, but I really shouldn't have done that. I should wait to do all my rounding at the end. Alright, let's go on to questions 3 and 4. So in question 3, we read the first sentence. We say an object's volume is measured by water displacement. And I want to remind you that in water displacement, that means that when the object is placed into the water, you're going to see the water level go up. So it goes from one initial volume to a higher volume. And so if we compare how the volume of the water changed, we'll know how big the object is. So the first volume is given as 70, and then the second volume is given as 72.9. So those two volumes, you take the difference between the two, and then you know the volume of your object. So that's the volume of the object. It also tells us the mass of the object is 6.13. So I'm doing the mass over volume to calculate density, and I got the density as 2.2. Again, units wise, I'm doing grams divided by milliliters. Number 4, we have a cube of aluminum, and it gives us the density of 2.70, and then it tells us the dimensions of the cube. So we have a length, a width, and a height. It doesn't really matter which variable you assign to which, but the important thing is that to get the volume, you have to do length times width times height. So that's all that's going on in there is taking the volume and multiplying it by the density to get the mass. So let's just throw the numbers in there real quick. So I plugged in the density, 2.70, and the length times width times height, and I threw this all in there. I haven't rounded it all yet. So I have the density times length times width times height. The calculator gave me 12,504.06655. It gives me way too much. So this is where our rounding step occurs. When you look back at the 4 values that we're multiplying together, 3 of the values have 4 significant figures, and the density has 3 significant figures. So I really only want to use the first 3 significant figures and round the rest away. So here's my answer. After I rounded it, 12,500. If you want to put that in scientific notation, you certainly could. 1.25 times 10 to the 4th. Both of them have the same unit, which would be grams. Let's move on to 5 and 6. So in 5 and 6, we have to be careful that we understand what we're solving for. And, well, we have to be careful in all questions, not just this one. So we're solving for the volume, and so I need to make sure I write the equation down correctly. When we're solving for volume, it is mass over density. So I wrote the equation volume equals mass over density first. And then I started just observing what I had. I was given the mass of 56.98 and the density of 19.32. I plugged those into the equation carefully, and I got 2.949275362. Of course, I didn't write all those values down. I rounded. This one, the rounding is pretty darn easy because both of the values have 4 significant figures, so I wrote down the first 4 and rounded the rest away. Units, be careful with the units. We have grams divided by grams, so they cancel each other out. The cubic centimeters do not cancel, and those are a perfectly acceptable unit for volume because that's distance cubed, which is what volume is. Number 6, we are looking for the mass. So again, I got to write the equation correctly. If I'm looking for mass, that would be density times volume. And so density times volume, I plugged in the density, I plugged in the volume, multiply the 2 values together, the calculator gives you 92.208. And then I thought about how to round it. I have 3 sig figs and 3 sig figs, so I only really want the first 3 significant figures. Okay, so in number 7, we're back to just solving for density. It does give us some weird units that really people get hung up on this. Units for mass are anything with grams, and it could be a prefix, so they gave us kilograms. So this is a big, heavy object, with a large mass at 45.67 kilograms. And then they gave us a volume in cubic meters, which is also a little weird. For most of the time we don't deal with cubic meters, but that's a cubic distance. That's a meter by a meter by a meter, so it is volume. And we just plug the values in, let the calculator handle the math. It gives us a really long answer, 12.7927 blah 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 blah. And we're only allowed to use the first 3 significant figures, and then after the third significant figure, we have to drop everything off. My pen is not working. So after those first 3 significant figures, I have to round the 9 and the rest away. That's why it rounds up to 12.8. Mass is kilograms per volume, kilograms per cubic meter. Number 8 throws some people off. The empty graduated cylinder has, and this is its mass. We have this empty graduated cylinder here, and it has a mass of 101.47. Then it is filled with 58 milliliters of water, and now it has a new mass. Well, that's because when they put the water in there, its mass will have increased. So if we subtract the 2 values from each other, like I did here, you'll find the mass of the water, 58.01. We also know the volume of the water. That's what this value here was. Ooh, now it's red and blue. That's exciting. If I know the mass divided by the volume, I have the density, which comes out to an even 1. Water's density is always very close to 1, assuming you don't have it in an extreme temperature change. So that's pretty convenient. Let's go on to 9 and 10. Alright, number 9 is just about the hardest question on the entire worksheet. So we have a mass and we have a density. And with mass and density we can get the volume. And so that's where you should start. But if you keep reading, you see that it gives you the height and it gives you the width of the object, but it does not give you the mystery length, or the mystery, how long it is. So I just had my 4th interruption making this video, so it's probably a little choppy. Sorry about that, folks. I'm gonna have to find a better place to hide. So where were we? Oh yeah, we know the length and the height and the width. We're trying to figure out the length. Well, I would do this in 2 steps if I were you. It looks like I was very ambitious here and decided to do it all in 1 step. I'm actually going to delete this. There we go. That was fun. And do it in 2 steps. So here we go. Let's do that. So there we have the mass divided by the density, and I got a volume of 2.493023256. Yeah, all of that is sitting in my calculator, and I want to use the number that's sitting in my calculator. I've only written down the shorthanded version of it. Now that should be equal to the length times the width times the height. I don't know the length, but I do know the height, and I know the width. So I need to divide these 2 values to the other side, and I'll solve for the length. So I need you to be very diligent in the way you plug this into your calculator. You should get 0.1362 blah 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 blah. But the way you do that is these 2 values both get divided underneath the volume. So it's 3.49 divided by 7.43, also divided by 3.45. That's how you get the length very carefully. And then there's only 1 centimeter left, because your length would be measured in centimeters here, and you have all 3 values. So 0.136 centimeters is the length of the object. Number 10, pretty straightforward. We're looking for mass. Mass is density times volume, so you plug in the density, you plug in the volume, you solve for the mass, and you round. Compared to number 9, number 10 was a piece of cake. Ooh, the following graph plots mass versus volume for gasoline. What is its density? So you could pick a couple spots. Let's just pick this spot here. We have a mass, let's see, this would be 250 right there. It looks like, I'm going to say 240 for the mass, and then the volume is right at 300. So that would give me the density. I'm going to pick this other spot. That's a nice spot right there. 600 grams over 800 milliliters. Let's see, 240 divided by 300. I got 0.8, and then I did 600 divided by 800. I got 0.75. So given that I'm estimating from a graph, those two values are relatively close together. It kind of a little bit illustrates the whole significant figures thing too, because I've really, once I got to this second value here, I'm not really sure that's a 4. I really should have an estimate on there. That should be 0.80. And that could be, this one here, certainly looks like it could be above the line. If I stick my face against the screen, I can see it looks just barely above the line. So it looks like it's slightly off. Cool. And this is just a bunch of mass over volume, mass over volume, mass over volume, mass over volume, and solving a bunch of times, paying attention to which of the values is limiting your significant figures. And I underlined which one was limiting me, and that's why those answers are like that. You could do some of them in normal notation. This one would look like that in normal notation. This one is just way too small, so you leave it as is. And this one's pretty big, or you could write 5,000 also. Either one of those would do. Alright, so in a minute you're going to do the lab on density. You have 4 metals that you're going to be testing. Pretty much you start with one metal, you find its mass, record the mass very accurately. Then you're going to do volume by displacement. Don't forget, when you do volume by displacement, that you need to read the meniscus as carefully as possible. Make sure you estimate between the lines. You know, so if it's between 23 and 24, you come in there and you go 23.2 or whatever. You want to get a good volume. Then when you put your metal into that and it bumps it up a bit, you then have a new volume and you make a really good reading on that new volume. So let's say now it's between 25 and 26, and it was 25.4. So the reason you have to give that second decimal place is when you do this math, you're not left with a whole lot of significant figures. That's 2.2 milliliters. So I only have 2 significant figures, which is to say my second value is already an estimate. So you have to do a good job reading the meniscus to get good data. You're going to do this 4 times for 4 different metals and calculate their densities. So you do the mass divided by the volume using the displacement method. The mass, of course, you're just going to put the metals on a scale. Make sure the metals are dry before you mass them, otherwise they'll be slightly overmassed and that'll throw things off. When you're done calculating all 4 densities, you're then going to do the percent error equation. And this equation is on the worksheet, but it clearly says that it is the experimental value minus the theoretical value divided by the theoretical value, and then since it's a percentage, after you do that you multiply it by 100. So the experimental value is what you are calculating. When you do the mass from the scale divided by the volume, these are the experimental answers here. The theoretical values are given on the paper. It says copper is, it says zinc is, it says lead is, it says it right on the paper. Just read the paper. Next class we are going to be going over worksheet 1 on matter, so make sure you've got that done. And we might be doing a lab next class also, pretty dangerous lab. So come prepared for a good lab next class. Thank you. Bye.